we will jump right in then. These are words you are familiar with. Polynomial, monomial. Mono means? One. So there's one term in a monomial. Polynomial is many terms. The degree of a polynomial, you find it by you're looking at the largest exponent, basically. Here's a little chart. These are things you know. You don't necessarily need to write this down. If the degree is 0, it means that we didn't have an exponent. There was no x. So y equals 2. That's just a constant. This is the name that goes with the degree. If it has a degree of 1, which we get from this exponent right here, makes a line. That's a linear equation, which, by the way, a constant, y equals 2. What does that graph look like? What do you mean straight line? They're all straight. Horizontal, there you go. And then a linear equation would be some sort of a probably slanted line. Quadratic equation, quadratic, even though that you want to think about that as a number 4 because you're thinking quarters and quadrants, it's actually a 2. So the degree is a 2 and it makes a what? A parabola. That's called a parabola. Cubic is where it has a degree of 3. Quartic is 4. It's not a word we use very often. Your calculator does have that in there as an option for your regression models when we get to that point. Quintic, that's not even a word that shows up in your calculator, but that's what you would say at a degree of 5. More than that, you just say whatever the degree is. Let's talk a little bit about parent functions. Now that's the original before you've done any transforming. You haven't shifted anything left, right. You haven't shifted it up or down. You haven't reflected anything over a graph. You haven't stretched it. It's just in its purest sort of form. And we have the identity function, which is y equals x. It's called the identity function because if x is 0, y is 0. If x is 2, y is 2. If x is 3, y is 3. So here's the line that makes. For the identity function, will this line ever do this? No, because it's an identity function. If x is 1 and y is 1, there's only one place for that to go. So that's the line it will make. Squaring function, the quadratic, makes the parabola. And here's what I want you to know about it. And this part might be a little bit new to you. You guys know what the words increasing and decreasing mean. You guys are very smart and you are older, so you know what those mean. But I don't know that you've used that when talking about graphs. You're going to see that a lot in calculus. It shows up a lot. So what we're talking about is when you look at the graph from left to right, just like you're reading a book. As I'm coming in from the left, is that graph increasing or decreasing? Decreasing. Decreasing. So we're going to say it's decreasing from negative infinity to 0. Notice I used x values. And if you wrote something down, that's probably the only thing that you probably need to write down. We're using x values, and you'd say negative infinity to 0 is where that thing is decreasing. What would I write for increasing? 0, comma, infinity. How come I don't use brackets on any of that?
Because infinity.
Right, infinity, you're never going to reach it. What about the 0?
Because it's not reaching.
Right, at exactly 0, it's neither increasing nor decreasing, or it's both, right? But you can't give it one or the other. So that's why we have parentheses there. Are there any questions on increasing and decreasing? That's probably the only thing that's very new at all to you today. Also, it's going to ask you today about minimums and maximums. Does this have a minimum or a maximum? A minimum, and it's at 0, 0. So when it asks you for it, you do give an actual address, an ordered pair. Notice this looks like an ordered pair. It is not. That's the interval for which it increases. Those are x values. This is an actual address. Alrighty, moving on. The inverse square function, you don't usually see this in graph form, but if your integer is odd, it does something like this. If your integer down here is even, it does something like this. You could type it in a calculator, it's going to give you the exact same thing. Cubing function, if you have not begun to recognize this little fellow right here as y equals x cubed, you probably need to know that. It's going to start showing up quite a bit. What you need to know about this guy is that this point 0, 0 right here for this graph is called the point of inflection. I know you've heard that phrase before, probably not a ton, but that's where the graph changes curvature. Meaning this guy right here, that's concave down, is what they call that in calculus. And I know you physics people are going to say, oh, well, this is convex. And in physics it is, especially when you're talking about lenses and those kinds of things. In calculus, they don't call it that. They call it concave up. Does everybody see the difference? Concave down makes part of a bowl that opens downward. Concave up is going to make part of a bowl that opens upward, if that helps you. So let me ask you, this one right here, is that concave down or up? Down. How about this one? How about this one? How about that one? Yep, those are both up. Alrighty? So that's a little bit new. The reciprocal function is going to look like this. This curve is also called a hyperbola. What you need to know about this one is that there's an asymptote along the x-axis and an asymptote along the y-axis. We're going to do some more with these in a few days, and you're going to see that sometimes those asymptotes get slanted. So I know you were exposed to that last year. You probably didn't do a ton with it, but we'll talk some more about that. Square root function. The only thing that I really need to make sure that you understand about this is originally this probably looked like y squared equals x. To get the y by itself, they had to take the square root, right? And when you do that, you're supposed to do positive and negative, yes? Well, they only graph the positive because if they graph the negative, it's no longer a function. Vertical line test, it won't pass it. So we only graph the positive. The cubed root function looks like this, and that makes sense because if you look at, where is it? The cubing function, this one right here. If you undo a cube, it's the cube root, right? Inverse, hopefully you remember this, it flips it over this line of y equals x. And if it gets flipped over that like that, looks like that. Exponential functions, we just covered a bunch of this right before the break. Thinking about like PERT, the PERT formula. So you see mostly these exponential functions show up in like finance and those kinds of things. This is the one where it's increasing, this one is decay. And then if you take y equals e to the x, if I want the inverse of e to the x, what is that? What's the inverse of an exponent? Yeah, natural log. So if I take this curve and I flip it over y equals x, then you have natural log, and it looks like that. So that's both of them together right there. That's the natural logarithm function. Power functions and log functions, same kind of deal. Depending on what that base number is, this is going to be either stretched or it's going to be really, really steep. The inverse of that would be a logarithm, so it just flips it over that line right there. Sine functions, cosine functions, you know what those look like. They bounce back and forth between negative and positive 1. What's the difference between sine and cosine? The parent graphs. Yeah, kind of where it starts or where it crosses. This one crosses at 0, 0, and this one crosses at the maximum. Absolute value, you can remember what those are because value has a V. It makes a V. This is not a rounded tip. That's an actual tip. There's a bottom point right there that is, and it changes direction. The greatest integer function, these always take me a second to kind of wrap my head around. Basically, it's asking for the largest integer that appears. So if you have f of x equals, and again, you've seen these, you probably didn't do much with them. Let's say that x is 2.1. Well, the largest integer that we have here is a 2. You don't round up, it's like rounding down every time is basically what's happening. So that if I go to 2.1, the value right there is a 2. If I go to 2.8, the value is still 2. You're rounding down every time. Does that make sense to everybody? That's why it's a step function that looks like that. So just be able to recognize those. A logistic function, these are used with half-life and radioactivity. In its parent form, before we've done anything to it, there's an asymptote at 1 and an asymptote at 0. Piecewise functions, it means what it says. It comes in pieces. This one's made of 3 graphs that you very easily can graph. Y equals x plus 1, you know that that's a line. but they only want you to graph it where x is less than 1. So you go back to, or less than -1. So you go back to -1, and there it is. We just graphed that piece right there. Then it says y equals x squared. You know that's a parabola. They only want you to graph it between -1 and 1. So that's what they did. And then y equals 1. That's your line over here, but only graph it where x is greater than 1. So they started at 1 and then graphed it. So it's in pieces. We're going to do some more on that in a couple of days. Here's what you got to be able to do today. They're going to give you a parent graph, or parent function. They're going to make you graph it, which you have a graphing calculator, or you can use a T-chart, and then you have to fill out this whole bit of information. You already know how to do almost all of this. Domain, what's that mean? The x values. They want to know where is x possible. How about your range? The y values. Decreasing and increasing intervals, we talked about that. You're only going to write down the x values, and it's going to look like an address, but it's not. So those are x values. X-intercept. Is x or y 0 on this? I just gave it away. Sorry. Have it. Sorry, have it. The y value is going to be 0 on those. For the y-intercept, it's where it crosses the y-axis. Say again? Okay. Minimum values. Is it possible that there won't be a minimum?
Yes.
Yeah, if it's a line or something, there won't be a minimum. Can you have more than one? Yes. If it says relative or local minimum, you can absolutely have more than one. What if it says absolute minimum? Do you know what that's asking for? Do you know what the difference is? Yeah, absolute is like the absolute lowest, and so there may or may not be one. So we just kind of have to look for that. Asymptotes. If it's a vertical asymptote, what's that equation going to look like? If it's a vertical line, what does it have to look like? X equals some number. I heard it. How about horizontal? Y equals some number. Continuous, they just want to know, are there any breaks? Are there any holes? What's the story with that? Most of them will be continuous today. Periodic, do you remember what that term means? Means does it repeat? What graphs repeat? Sine, cosine, tangent, and then the reciprocals, right? So you just say yes or no. What type of symmetry? You've got 4 possible answers. None is an answer. About the x-axis is one answer. That means it's the same on the top and the bottom. About the y-axis, that's your third possible answer. That means it's the same on the right and the left. It flips back and forth. Or it could be symmetric about the origin. Do you guys remember what that means? Yeah, it kind of goes around the point. Like, let me find, where's that one? Here we go. This cubic function here means if I hold it in place on the origin, and I spin it, it's the same graph upside down that it was right side up. So when you flip it 180 degrees, it's the same. So that one would be symmetric about the origin. And then is it piecewise? Basically, if there's more than one equation written, it's piecewise. That's kind of it. Last little bit and I'll be done. Just to make sure we understand increasing and decreasing. If here's your picture, and they want to know where is it increasing, even though this arrow is pointing down, we go in the order that we read. Left to right. So that's increasing. So it's increasing from what to what? Negative infinity to -2. And what to what? Good. So for oh, sorry, I wrote that. You couldn't even see it. My bad. For decreasing, there's decreasing, right? What do I put? -2, comma, +2. Notice that those are not brackets. Those are parentheses. This little guy right here, is that concave up or concave down? Concave down, and this one would be concave up. Is there a relative or a local minimum?
Yes.
Yes. It's this little address right here, and you would put 2, -16, and then there's also a relative maximum. It's relative or local because there's not an absolute minimum, because this thing goes down for forever. There's not an absolute maximum because it goes up for forever. So everybody see the difference? Last little thing, grab your calculator. Go to mode. Make sure you are not in polar anymore. Make sure you are in function. Function. Hit y equals. And type in 3x squared minus 4x minus 2. Now your window could be all kinds of messed up from the semester test. So already hit zoom 6, and that's going to reset it into that little pretty 10 by 10 grid. If it asks you what the minimum is, and obviously it's kind of shady where it is, do you know how to find it? Hit second, calc, trace. We're looking for a minimum, so hit 3. And it's going to ask you in the bottom left-hand corner, it's going to say left bound. It means get the cursor somewhere on the left-hand side of the minimum. Mine's already there. Hit enter. Then it says right bound. It means move that cursor to the right-hand side of the minimum. Hit enter. Guess, enter. And your answer should match mine. It should be 0.66, comma, -3.33. The reason it asks you to do left bound and right bound is for some of these graphs there's more than one minimum. Your calculator is really smart, but it cannot read your mind. So you have to tell it which minimum you're looking for. And that's why we had to tell it we want the one that's between those two points. Okay? Questions? Last little thing and I'm done. I kind of released first hour at this point. I stopped taking notes and we were done. And then I realized I kind of also had the same question. So when you get your packet in a second, it's going to ask you to graph lots of things. Let's say it wants you to graph y equals x cubed. You graph it, and it looks like that. And the first thing it's going to say is, what's the domain? And I know you guys can say, oh, it's the x's. Do you know what to write? We're going to write interval notation, by the way. Is there anything that x cannot be? X can be everything, right? And you can tell by looking at the picture. This thing, yes, it's going down, 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 but it's also gradually going to the left, right? So technically, eventually it's going to make it all the way over here, and then all the way up there to the board, and all the way through to Canada or whatever, right? So I don't even know which direction we're facing. How terrible is that? So the domain is x can be anything from -infinity to +infinity. How about range? It can be anything. It's going all the way down and all the way up forever and ever. What if, though, what if it asks you to graph y equals x squared? What's that domain? Domain is the same, -infinity to +infinity, because these are gradually going right and left for forever and ever and ever and ever and ever. How about the range? 0 to infinity. You're looking at the y values, that's up and down. Started at 0 and we went up to infinity. When you do the range for that, is that going to be parentheses or a bracket? It includes 0. Alrighty? Just to make sure I said that. Okay, let me kind of get this thing shut off for a second.